In this video, we're going to prove that the product of the gradient of two perpendicular lines equals -1. So you might have seen this rule, okay, that if we have two gradients, okay, the two lines that are perpendicular to each other, if you multiply the two gradients together, you get -1. So in this video, we're going to see why, or at least one proof as to why this in fact occurs. So here's a coordinate plane, so I've just drawn that in red. I might just zoom in on that. Okay, and what I've done is I've drawn two perpendicular lines. Okay, so they are in fact perpendicular. I've indicated it here with a square. And here's this line, so let's call this starting from the origin O. Okay, this is the line y equals m1 times x, or m1x. So the gradient of this line is m1. And I've drawn the other line that's perpendicular to the first line. So the second line here, this is the line y equals m2 times x. Okay, so we know that if we multiply the gradient m1 by this gradient m2, we know we're going to get -1, but let's see why. So what I've done is at the point where x equals 1, I've drawn a vertical line. And this vertical line intersects the two original lines. So I'm just going to draw in the point of intersection there. So let's call this point A, and let's call this one here point B. So the next thing we need is to find the coordinates of point A and point B. Now notice that this line, this vertical line AB, okay, or this interval AB, passes through x equals 1, or crosses the x-axis at x equals 1. That means that the x-coordinate of A will be 1, and the x-coordinate of B will also be 1. But what about the y-coordinate? Now, we get the y-coordinate by substituting in the x-coordinate into the equation of the line to get the y-coordinate. So if the x-coordinate is 1, and we're multiplying it by m1, that means that the y-coordinate of point A will be m1. Now, for the same reason, the y-coordinate of point B will be m2. So when you substitute x equals 1 into the equation y equals m2 times x, well, m2 times 1 is just m2. And we now have the coordinate for point B. Now, triangle OAB is a right angle triangle. That means then that Pythagoras theorem should hold true, and it will hold true, of course. The hypotenuse is given by, or shown by interval AB, and so we have the two shorter sides, OA and OB. So, by Pythagoras theorem, okay, so okay, I might just zoom out of that now. Okay, we have AB squared is equal to the sum of the square of the two shorter sides. So we have OA squared plus OB squared. And we know that this holds true because it's a right angle triangle. So we don't have to prove Pythagoras theorem here. We're using this fact to show this relationship. In fact, is in fact true, and hopefully come up with a relationship that shows that m1 times m2 hopefully will give us -1. Now, we need length AB. So this is this vertical line here. So because it's a vertical line and it's the x coordinates are the same, we only need the difference in the y coordinates. So AB squared is in fact given by m1 minus m2 all squared. Yeah, so that's the hypotenuse squared. So m1 minus m2 is the length of the hypotenuse, but we need to square it because we're applying Pythagoras theorem here, is equal to, now, OA squared. So let's see what that is. So OA squared, if you look at this smaller right angle triangle, so it's like a nested right angle triangle. It's a right angle triangle inside the larger right angle triangle. We have the short side, one of the short sides is 1. This vertical short side is in fact M1. Okay, so we're only focusing on this top triangle here. The hypotenuse, or the smaller hypotenuse OA, is just only in this local right angle triangle there. Okay, is going to be given by, well, the square of the hypotenuse OA is 1 squared plus M1 squared. Okay, we don't need to take the square root of that because OA, this length here, OA, is already squared, which cancels out the square root. That's why I'm not showing a square root here. So for the same reason, OB squared, that's going to be 1 squared plus M2 all squared. Okay, because that's also a right angle triangle, just an upside down right angle triangle there. Okay, we have the short, one of the short sides is 1 unit across, and it's going to be M2 units down, or M2 units in length for the other shorter side. So the hypotenuse OB is actually 1 squared, or the square of the hypotenuse OB is just 1 squared plus M2 squared. Now let's expand the left hand side. So we have M1 all squared, that's a perfect square, minus 2 M1 M2 plus M2 all squared is equal to 1 plus M1 squared plus M2 squared plus 1. I'll put these back to front, doesn't really matter. Let's cancel out the M1 and M2 squared, so M1 and M2 cancel with M1, M2 there, which leaves us negative 2 times M1, M2 is equal to 2. 1 plus 1 is 2. Now if we divide both sides by negative 2 to have M1, M2 as being the subject of the formula, so M1, M2 is equal to negative 1. So this is what we've seen before. M1 multiplied by M2 is in fact equal to negative 1. So that is one proof of the product of the gradient of two perpendicular lines is equal to negative 1.